I've neatened all of this up a little bit now, and if we look, we've got from our various parameters that we wanted to implement, we've got grain length, we've got grain transposition, we've got grain position, and we've also, which I haven't put a label on, we've also got envelope as well. So what we haven't dealt with yet, of course, is grain interval, and for that to be relevant, we would be looking at having multiple grains happening, well, I say at the same time, but in quick succession. So this is where we want to implement this kind of engine within a sort of polyphonic context. And for this I'm going to go back to, or refer you to a tutorial that I did earlier on, which you will find in, I'm referring to my website, which has all of the available Max tutorials currently on it. And there in percussion and sampler and simple polyphony you will find a sort of an engine which enables you to have multiple sounds running at the same time, and I use it within a kind of clatter model. So just to save a little bit of time, I've built a kind of shell for this. So let's open that up, and here you will see, again, if you've seen that tutorial, this will be familiar to you. We've got this means of routing messages depending on a counter kind of controller to different voices, which in this case contain currently very little. I've just put in the inlets and outlets, and at the end of that we have a sorry, it's a bit too big at the moment, can't see it all. There we go. At the end of that we have a volume control and an easy DAC out at the end there. The thing with this is that, just to point out, I'm not actually sending any information along with the count. So in prior examples I've used the root object to root a list that was prepended with a number which was absorbed by root, and then the remaining list was sent to these voice objects. In this case there is no additional message, there's nothing additional to that number. So in fact in this case root functions as a select object, is basically what it's doing, and having got the number from counter it simply sends a bang out to the voice, and I'm going to use that bang to trigger our grain, as we were doing before. So there's our engine, and once we've popped this into there, we should be able to get a series of grains happening one after another. So yeah, the first thing really we need to do is to enable information from a sort of a front end or an interface to reach these parameters within each voice. So we will have this, and we will have we'll have all of our controllers on that front end, and their information will be sent to the voices themselves. So we need to pop in some send and receive objects. So in this case I will put receive grain length, receive trans for transposition, or grain trans. I will have grain position, and I will have grain envelope. So obviously I'll need to pack and unpack that information from you know, in order to get into oops, in order to get into the voice. So we'll do that. And of course that means that we'll therefore need a send to send that information as well. Yeah, so we can get rid of this. And we'll need a pack object, PAK, so that if I change the latter part of the envelope, it will still be sent to the trapezoid object. Because of course the right hand input of pack is still a hot inlet. Of course I'm going to pop these down here for the time being. Oops, move it out of the way. And then I'll move them into the main part of the interface in just a minute. So we can put this here. We can put grain length, just make sure that I connect it to the same parts of the patch that I connected the grain length slider to. So this one is grain length. It'll probably be safer actually to pull down the receive object and just change to an S, because if I do that then at least I know that I haven't made any spelling mistakes, but never mind, I'll leave it as is for the time being. Grain transposition, so I'll move this one up to here and replace this number box. And then the grain position will be going to here, which of course makes the patch slightly neater as well. Not much, but a little bit perhaps. So in fact, all of this information here will now go into the main part of the patch, so I'll do that right now. Well, I can doesn't really matter whether I copy it or cut it really, I'll cut it for the time being. Oops. So pop that into there. So obviously I would use the presentation mode to neaten that up in due course, but it's alright for the time being. So I can now go into one of my voice objects. So in order to do that I can either right click and go down to Object and open Original Voice, and that will open the original patch, because at the moment of course if I open it straight then I can't unlock the patch or make any changes to it. So I could either do that by using that right click method, or if I open up the abstraction so that I can see it, but again I can't make any changes, and I can't make any change if I see these brackets around the name, then I know that I can't make any changes. But if I right click up, oh sorry, not there, if I alt and click, sorry, on that title bar and then click on voice, then it opens up the original patch again, and this time you notice that there are no square brackets, so I can unlock this one and make any alterations to it. The first alteration I'm going to make is to bring these down here, because if you remember these are our through inlets and outlets. Again, you'll need to refer to the patch I did last time to see what I'm talking about if you don't already know. And then I can I'll copy it this time across into here. And simply send those to our outlets. And then of course I need, from the inlet, I need to send through our button object. It doesn't really need to be through the button object, it could be directly to the integer object in order to trigger, and then this left-hand outlet is redundant. Again, you'll remember that if you saw the previous example. So I'll leave this over on the left-hand side a little bit. Again, it's not terribly neat, but it should, I hope, do the job. Otherwise I'll have to come back and make some changes, but that should be okay. So now if I save that, we should find that all of our voices have been updated. And now, yeah, of course I need to reload the sound into there because I've moved this. So we'll go to spoon drops again. Make a selection, and I need obviously to so grain transposition will be 1. Obviously I would probably send load bangs to all of these to initiate them. Again, this is good practice if you're making a patch. And we will make a grain envelope of 0.1 to 0.9 and turn up our volume, which I'm having to do independently at the moment, but we'll come back to all of that in a minute. So hopefully, so now you can hear that I can have several sounds happening on top of each other. And if I move this through the patch, again I'm not getting any clicks when I do that. Hang on, does that actually send? No, because I haven't sent my grain position out yet. So I need to. Luckily, it was running from millisecond 0 anyway. Yep, so that now works. I was bound to make a mistake, but that's again that works. And so now we just need to specify our grain interval, which we can do very simply by using a metro object and choosing how rapidly we want bangs to be sent and counts to be made in order to trigger each of these voices. So I could, well, I'll start off with 100 milliseconds, but of course I can change that very easily. Let's put in a toggle object, and a means of changing that rate. Is that down a bit? So we are moving through the sound. And of course, if I were to automate the process of reading through that sound, I would get a kind of granular sound. You notice, of course, that we're hearing this before I reach the sound because our grain length is relatively long, although you can't actually see it because I could probably do with having some means of visual display there. So I was putting a float of that there so we can see how long that actually is. So we have a grain length of 433 milliseconds at the moment. So of course, what we're hearing is the end of the grain there. But I can make the grain length shorter, and of course we cease to hear it until we're much closer to the sound. And I mentioned actually walking through the sound. Of course you can do that. If I were to use a line object here, actually what I should do of course is to save this, otherwise it's going to crash and I'm going to lose it all. Grain generator, you can see I've made some versions here, but I shall call this tutorial 1. except that I shouldn't have put it there because of course my voice patch that I changed was in this folder, so I shall have to make it again in there. Yeah, so you could use a line object very simply to read through that data, as long as we know how long it is, which, if you remember, it happened. I just happened to know that it was about 14 seconds long, that sound. We did find that out earlier. Or of course I could find it out properly by sending a bang into there and then having the output, the total time, going into a number box just to tell me. But I know it's roughly 14 seconds long, so I can say read from 0 to 14 is that right? 14 seconds into the file over a period of I don't know, let's say 40 seconds. And I can get Line to do that for me. And we get a granular time stretch. And of course, by changing the grain length, notice incidentally, I'll have to change this in a minute, notice that we're getting a kind of transposition when I change the grain length, just temporarily while I'm changing it. Actually, we probably wouldn't want that, so let's see if we can deal with that for a minute.